When we designed our system the first time, we assumed that 100% of our rainfall went into our inlets. We're now going to redesign our system using bypass flow. To activate bypass flow, we need some bypass flow strings. So let's maximize our plan view. I'm going to turn off those excavation sections just to clean up the view a little bit. And then I'm going to add on our DWG overland flow strings. Now these strings were drawn inside AutoCAD and brought in when we brought in our catchments and our drainage layout. Now what's done with these strings? First of all, they're drawn in the direction of flow. Now in this example they happen to be following the pipes, but that's not required at all. In order for them to be recognized by an inlet, it must pass within one manhole diameter of that pit. So essentially, one manhole diameter would take us out to about here. So as long as the line passes within this range, then it will be recognized for that pit. Something else that will happen with these overland flow strings is they will be used for overland flow flooded widths and depths. Cross sections are going to be cut perpendicular to these lines, and the slope is going to be measured along these lines. So a little bit of care is required for drawing them if you plan on doing flooded width calculations. Zooming out down here, you can see that this bypass string goes past this inlet and then essentially leaves the inlet, leaves the entire network. When this happens, 12D just considers this bypass flow lost from the model. Now you can draw these strings, but it's often more common to take your road design strings and just take your invert of curve, copy those into a separate model and use those instead. Of course, checking to make sure they're going in the correct direction. The easiest way to make sure those strings are going in the correct direction is change it to a line style where you can see the direction of the string. To do this, we'll go up to Utilities, down to A to G, and then select Change. The model that we're going to change our style for is our DWG drainage network. And what I'm looking for is a new line style. The line style I'm going to find is found in Drainage 12D, and it's called our flow line style. I don't want to copy these, I'd like to just replace them, and then I'm going to select the change function. And it says that we're finished. Pardon me, looks like we selected the wrong model there. We're looking for the DWG overland flow, select change, and now we've got a flow style so we can see the direction of those strings and all as well. To implement these strings, we have to return to our drainage network editor. So if I go and select the drainage network, move over to our global tab where we've done all of our other links on the utility models, and we're now ready for our bypass flow. Now the bypass flow we're looking for, once again, is DWG overland flow. And to make all this active, we once again return to the set pit details. Now with the set pit details, it pops up there's some troubles in the background. We've got these clearances, which looks like it's gone back to that 1 millimeter. We'll have to fix that one up. And we also have a trouble here, so we're going to have to go back and fix these up to find out what the trouble is. Now this pipe cover limit, that one will be quickly fixed by regrading our pipes. So that one is pretty easily to take care of. Go back to set pit details again, and you can see that it's taking care of everything else, but we still have that one grading problem with that pipe. We'll fix that later. What we're really interested in seeing, I'm going to close this right now, is going to our pit tabs and going and looking at the bypass tab. On the bypass tab now, we have this field indicating the bypass pit. So we're at inlet 01 here, and if any water does not make it into inlet 01, it's going to bypass into inlet 02. So that's how we know that we've got our bypass calculations happening correctly. It's by checking that bypass pit field. When considering bypass flows, it's important to configure your inlets as either sag pits or on-grade pits. Let's maximize our plan view and then add on the tin design to take a closer look at whether our pits are sag pits or on grade. Inlet 05 has water approaching from upstream and then continuing on by. So the water will not pond at this location, definitely an on grade pit. What will determine how much water goes into this pit is the road crossfall and the road grade. The steeper the crossfall, the more the water will be pushed against the curb and the more the inlet can capture. The steeper the grade, the closer the water will flow to the edge of the curb and gutter and the more will get caught, until the point where the water goes so fast and has so much momentum that it will travel straight by the inlet and therefore capture less. So therefore road crossfall and road grade will affect the inlet capacity of an on-grade pit. Moving out, let's take a look at a sag pit. A sag pit is different. A sag pit, the water approaches from all directions, and if it does not have inlet capacity enough, it will pond up, and it will pond until it fills up to the lowest point around its catchment, when it will overflow and continue down the roadway. So changing from an on-grade to a sag pit is an important part of your bypass calculations. 12D has a feature that will automatically locate sag points along your strings. We can find this under Strings, down to Label, and Label Changes. Now it seems a strange place to find this, but one of the label modes is to label crests and sags. Now the crests and sags we'd like to label are going to be found in our strings models. Because they're going to be in several models, we don't want to choose the model selection, but rather the view selection. We don't necessarily want to label all of the road strings. Therefore, to limit our selection, we're going to go all the way across and use our filter button. Now, if you haven't used the filters inside 12D, it's a powerful feature for selecting strings across your entire project. So the first thing we're going to do is we'll return back to view number 4, where we have all of our road strings. However, currently we do not have our curb returns added, so let's go and add those as well. Now those are going to be our road, scanning down here, the road curb returns, and we don't nearly need the section, so we might as well just have the strings. There's the strings, and there's our 2-to-1 strings, and the other curb return strings. So those are all of our curb return strings on there right now. Looks like I missed one. Let me just go back and add on that. Curb return strings. There we go. Now zooming in a little bit closer, let's just do a double check on the string name that we're looking at labeling. Bringing up my string inquire, what we have back here is the left invert, and down here we have our left invert again, and so we also are going to have a right invert. So if we zoom across over here and check the inverts of these curbs, we're going to have these ones are also a left invert. And do we have any right hand turns in this model? There's a left hand turn, left. Okay. Double check over here. And that one, if we check our string name on that one, a little closer, that one's also left. So it looks like all of our turns, just by chance, are all left hand turns, so left inverts. However, if we look at the main road, on the northern side, we're going to have a left, and we're definitely going to have a right invert. So when I go to select these, I'm going to select all of my strings from view number 4, but I'm also going to move across here now to string info, and I'm going to restrict these by putting in a wildcard I and V. So the idea here is we're only going to label the invert strings. Now moving down farther, we have to put these labels into a model. Now down here we have the model for labels, so I'm going to put DR for drainage, and I'm going to call it crests and sags. Now I'm also going to highlight this and take a copy of it because I need it again in a moment. Now I'm really not that concerned about the changes, but if I was labeling these, I'd probably be more interested in knowing the height of the sag point. Moving across to the Marks tab, I'm going to put my marks into the same model and do a Control V to paste that in. Hitting the Enter key to validate it, it makes the rest of the fields active. The mode for my marks is I'd like them tick centered, and rather than having a 1 meter long mark, I'm going to make a 10 meter long mark so that I can easily identify the sag points. Now that I've done that, I'm going to hit the label button, and it tells me that I have not selected my text style for my labels. So I'll do this right now, and I'm going to use my Arial 4, and then I'm going to label that again. It says they've been labeled. If I come up now and add on my drainage crests and sags, drainage crest and sag at the top there, you can see that I've got a large line indicating exactly where that sag point is around that curb return. Now if I zoom out a little bit to see if there's any other locations, I can see that there's some at the top here. And these are where we have crests and sags immediately adjacent to each other. This happens whenever you have a flat spot on your strings. Now, probably a horizontal. Now we also have another sag location up here. So you can see it's quite easy to find your sag locations using this label by chainages. Now that we've located our sag points along our road, let's double check to make sure that our inlets are at these sag points. I'm going to return to view number 1, and I'm going to come up and add on the drainage crests and sags to this view. You can see that we don't. Our drainage network is up here, and we want to move that inlet down here. Now if you recall, whenever we have our network editor open, it locks our strings. Therefore, we're going to have to close the network editor before we can do any plan changes. Then we're going to go up to strings, down to points edit, and we're going to use the move command. Now the one we're going to move is our drainage, so that's our labels, labels, labels. That's the one we're looking for, drainage 12D. Now where I'd like to move that to, middle mouse to accept, is the intersection of our back of curb string and the crest and sag string. Now to do that, I can quickly do a right mouse click, go to my snaps CAD, and go to my intersections. And what I'm looking for is just intersecting two segments. Following the instructions it says down here below on the left, I have to select my first segment. Well, my first segment, of course, is going to be my crests and sags line. That's the first one. The second one's going to be my back of curb. So there's my crests and sags. So what I'm looking for is another one of my strings. Now, of course, the reason I can't find that is because I do not have my strings on this model. But even at this point, I can jump back to my view number 4, zoom into here, and grab the back of curb string off this view. 12D has the capability to easily jump between views while you're doing these type of functions. So that is where I'd like it to be, at the intersection of that, the back of curb and the sag line. Accept that. And now if I jump back to my original screen number 1, you can see that my inlet has been moved. Now keep in mind, anytime you do any changes in horizontal geometry, you're probably going to want to regrade your pipes to readjust your cover. So I'm going to select finish on that. Now I'm going to grab my network editor again, come back here, pick my drainage network, and then come back and regrade my pipes. That regrading is important. I know about that clash, because now we have the correct cover on the new location for our pipes. Now that we've correctly located our inlet at the sag location, let's check our sag depths. To do this, we're going to bring back our network editor, move it across to the side, and go select that inlet. If we move to the Pit tab, across to Bypass, you'll notice that this is currently configured as a manhole. Let's change this so that it is an SAL2D. Now that sag, S stands for sag, and inside our drainage.4D file, we have a pit configuration set so that it is definitely a sag pit, not an on-grade, and not a manhole. So now that we have it as a sag pit, we're going to come across and hit the set catchments. That makes sure that it has a catchment associated with it. And now what we're going to do is to have it calculate our ponding depth for us. Now we could select the manual button and type it in manually right here, or we can come back with that turned off and go set pit details. Now this automatic calculation, I'm going to go hide this for a moment. What it's done is it's gone and found the lowest point on all of our catchment strings linked to inlet IO6. It's then taken the grate level. The grate level is calculated in this case from the back of curb minus 150, and compared it, the two levels. Actually subtracted. It subtracted the grate level from the low point. The low point will be in this area somewhere. Now that's turned out in this case to be minus 0.008 meters, 8 millimeters. So the low point is lower than the sag. Now this isn't supposed to be the case, and this is caused by the fact that when I drew my catchment string, I was not very careful at all, especially in the low point. So now I'm going to have to come back and change my catchment string to more carefully follow the crest around the high mark of our catchment area. To help accurately identify the crest of our catchment, 12D has an option to mark the crests and sag locations, ridges and valleys, of your tins. To do this, we'll move up to Tins, go down to Tin Analysis, and select Ridges and Valleys. The ridges and valleys we'd like to have marked are going to be for our design tin, as we cannot do this for the super tin. And we're going to create our ridges, so I'm going to put DR as a prefix, ridges. And then we're also our valleys. Now we're not really interested in the valleys, but we'll get them anyway, DR valleys. And the experimental fast method is fine to use. It's been experimental for a while, it's pretty good. Select and calculate. You see it's calculated the ridges and valleys. Now it's going to get a little bit cluttered on this drawing right now, so I'm going to turn off that design tin to make it a little clearer. I'm going to turn off that sag model, and I'm also going to turn off our labels until we replot them. Now what I'm going to add on now is that new model called the drainage ridges. And you can see what the trouble here was, is the ridge is formed along here, and I've gone and taken a couple shortcuts and cut right inside. So what I'm going to do is try to follow that just a little bit more closely. Now to edit this, first of all, remember that our network editor is going to lock all these strings. So I'm going to finish it to get out. Now I'm going to come back here and add on my DWG, drainage catchments, and come back and work on this one area. I need to insert a few new points. I'm going to come across to our vertex, drag this all the way across to the insert mode. So I'm going to select my catchment vertex, come out and bring this out just a little bit closer to that ridge line, snap on there. And I'm going to do that again for here, bring that out and snap onto there. And I think I need to move that point. Let's check out here. This is looking pretty good for around there. Cutting across. Looks like I'm a little bit out on here. I'm going to insert a new point for here, and then I'm going to come back and move this one. Now I'm finished the inserting. I'm going to come do the moves. I'm going to drag this across and use my move point. I'm going to grab this point on the catchment, bring it over to the edge of that crest, and at the same time I'm going to bring this one, bring it back to the edge. And now it's looking a whole lot better. Just this one last point up here I'm going to pick up and move. Actually, I might do two more. And I might as well take this one while I'm at it and put it a little closer to the curb as well. So by snapping onto that string, and now I've more accurately defined the crest. Now you can see that the sag that's going to happen here, the ponding, is going to be very small indeed. However, it is going to hold the water, and it is going to cause this inlet to act like a sag pit. Now that we've altered our catchment ridge, we're going to come back and recalculate our pond depths. Back to our network editor, going and selecting that inlet, and you'll see once again we're going to go back to the pit, down to our bypass, and come back and do our set pit details again. Now you'll notice now that our ponding depth is positive, 2 millimeters, so really not much of a ponding depth. So what we should do is, just as a double check, is to confirm our grate level. To check our grate level, what we would do is we go back, make sure we're on the pit tab, go to main, and come down and check our grate level, which is sitting at 28.485. Now we should also compare that to our setout level. So if we go check our setout level, which is supposed to come off our back of curb string, we can double check that. Our setout Z mode is 635. So 635 minus 150 should give us our grate level, and it is. So we've fairly accurately modeled our sag here. Unfortunately, it is a very small sag indeed. When we look at the inlet capacity of an on-grade pit, we need to know the road grade and or the road crossfall. Now, if you specified or linked your manhole to a road design string, we can take the direction from your road design string to measure the road grade. If you specified the center line of your road, then we're able to go between the road setout string and the crossfall string in order to measure the road crossfall. Let's take a look at where those values were calculated. I'm going to zoom in quite close, and I'm going to add on a model called construction drainage data. You'll notice two small tick marks appear. First of all, measuring the grade. What 12D has done is it's gone one manhole diameter upstream and created a small tick mark. That tick mark is the distance over which it measures the grade. It does not take an instantaneous grade off the triangles, but measures the level here and the level here and divides it by its length. Now, in order to measure the road crossfall, it comes across from this one manhole diameter towards the center of the road. So if we take a look, that's where it's gone, towards the center of the road, and that's where it's measured the crossfall. If you ever wanted to check these, you'd be more than welcome to profile these strings to get the length and the grade off them. Now, there are cases where your manhole could be quite close to the curb and gutter, and you might want to take this measurement a little closer to the center of the road. Or you might feel that we took this grade a little too close, and you might want to measure the grade farther upstream. You can change all these settings inside the the network editor. So let's go grab our network again, go back to our global utility models, and go back to our road design model. And we're going to open that one. Here's where we get to control the settings for where the road grades and crossfalls are measured. Now currently we have not put any values inside here. What we could do is come and change and put the grade offset and the crossfall offset to determine where 12D, or just how far 12D would move upstream of our inlets and from our from the center of the pit towards the road center line before it measures the crossfall. Now that we've altered the horizontal and vertical alignment of our drainage system to make sure that we had an inlet at the sag location, we might have noticed that some messages were occurring in the background window, the output window, whenever we were doing a regrade or a set pit details. So let's try that regrade pipes again. It says that our service clash has come back, and it says we're short 21 or 22 mils at this location. So let's go back and we're going to add 0.022 22 millimeters on our pipe design tab and then say regrade our pipes. Now you'll notice that it's changed to an info warning and we've got an extra mil of clearance. When we were going set pit details, that also gave us a warning. It said that inlet 06, the setout distance, seemed too large. We had set that as 1 millimeter, the setout distance, and we wanted this warning to come up if we ever placed an inlet not directly on the back of curb. Now we did place this on the back of curb, however, the only road strings we used were the ones on the straights, not the curb returns. So it is a little irregular to put an inlet on a curb return, but what we should do is include that in our road design file. So moving back to global, utility models, we're going to edit our road design file. Now to keep my road strings together, I'm going to select this row here, do a right mouse click, and say insert above. Now a quick way to insert something new is I'm going to click the one above, do a right mouse and say copy, select the line before, right mouse, and do a paste. Now I could have just as easily rewritten these values inside here. Now to get the name of the road strings, I'm going to move back to view number 4. Here's where I had that model of my curb returns. So what I'm going to do is a middle mouse click inside this cell. A middle mouse click inside that cell, and then going and picking one string from that model. And you'll notice that middle mouse click, which is the same as button, loaded the property of the model name from that string. Now I'm all done, so I can write that file out. Yes, I definitely want to overwrite it. Select finish, and then go back and do my set pit details. Now you'll notice there that the I06 still says that it's too large. So let's go back and double check to see what's gone wrong. If we go back to our pit tab and look for our setout, it's still linking to the road strings. What happens here is 12D, once it's established a link, that link will always remain even if a better one comes up. So what we must do is clear that link. Now we could manually clear that, or if we go back to our global utility models, we have the option to clear all of our road links. Yes, we're sure. So now all of the old links have been removed. And if I come back and do a set pit details, it's now going to find the closest ones. And you can see that I06 now has a set out distance of 0. Let's check to see what this has done to our pit levels when we come back to our bypass. Our bypass sag pit has now substantially increased. We're up to 34 millimeters. So that's what our trouble was. The trouble was the set out point was coming from back here, not on our curb return. Now, if we ever had gone and done a plot and go plot again, one of the symbols that comes out in our plots is our set out coordinate. So I'm going to return to view number 1, and I'm going to come and add those drainage plot labels back on. So drainage 12D labels. That symbol there is the one we're looking for. Now if we had noticed before, that symbol there would have been located all the way back over here on the road straight. Another indication that our set out point was incorrect. So you've just seen 2 additional features to identify if your set out is not being calculated correctly. 1 was that warning in the output window. 2, that set out symbol is definitely would have been shown in the wrong location. To review the details of our bypass calculations, let's go back to our network editor and look at our hydraulic report. So going back to our network editor, going and selecting our network, back to storm analysis, and we're going to rerun this, make sure you have the most current results, and go back and open up, cancel on that, go back and open up our hydraulic report. I'm going to do a Windows freeze pane on this one, just so that I can see my pipe names in the first column. Now the one we're going to examine is I06, the one that goes across the road. So you'll notice that whenever 12D goes and sizes a pipe, it has to come up with the peak flow. Now it does 2 calculations as we discussed before. First of all, it calculates the peak flow if it was going to use the TC from the entire area. Now that TC is going to be the TC of the longest path, and that flow turns out to be, in this case, 267 liters per second. When it goes and does the partial area calcs, the partial area calcs come out to be 320. That's the critical. So the peak flow from the rational method calculations is 320 liters per second, and that results from a time of concentration of 5.2 minutes. Now it's this flow that we're going to use when we use our bypass. Now this introduces the concept of the net bypass flow. The net bypass flow is the above ground flows, and if we return to our drawing, minimize this, what it is it looks at any external catchments, okay, that are coming into this. That counts as a positive bypass. Then it looks at any bypass leaving this one. In that case, it's minus 101. So what it does, it takes all the inflows bypasses minus the outflow bypasses. And of course, there are no inflow ones this time externally, so we wind up with a minus 101. Now the 101 is subtracted from this peak rational flow. Now the rational method, if you ever add up the flow in all the pipes, it never equals the flow in the downstream pipes, and that's because the time of concentration becomes longer and the discharge drops off. So therefore, it's this peak rational flow that the net bypass flow is subtracted from to get the flow in the pipe. And it's this flow in the pipe that's used to do all the hydraulic grade line calculations. So if we return to our results and check that 219, we zoom back out, of course it's rounded off, but there's the 220 liters per second, which is the flow in the pipe that's used for your hydraulic grade line calculations. We began this demonstration and tutorial with a set of bypass strings. Let's now look at creating those bypass strings from our road design strings. So I'm going to close our network editor, go back to the editor and select finish. I'm going to return to our view number 4 where we have all of our strings on one view. I'm also going to come back here and turn off a couple of models that we don't want. the services. The road center lines I think we'll keep. I held the control key down to turn that back on. And now we have all of our strings. So now what I'd like to do is to grab the invert strings only and to copy them into another model to make them our bypass flow strings, and then change the direction at the same time. If I did a string inquire for this string here, you'd see that our lip of curb follows all the way through this section. Now, the nice thing about the lip of curbs is they do tend to follow all the way through all of our project. The only trouble with them is that when we're doing a curb return, the lip of curb is not usually used, but rather it comes up with a different name. So if we come back one step farther and we look at the inverts are fairly good for these. The only trouble is they won't take us across intersections, and we will have to do manual work to our strings. So with that limitation, I think we'll use our invert strings in order to calculate our bypass strings. Once again, to do this, we're going to use our utilities, A to G, change, and we're going to use our filter functions. So once again, we're going to apply the filter. We want all of the strings that are currently on view number 4. So we'll select view number 4. But we're going to use the name of the strings in order to select them. So the name is going to be a wildcard, INV for invert. Then when we create the new ones, we're going to change the line style. And we're going to change the line style to drainage12D, flow line. This will help us determine the direction of the line to see if they need reversing. Now in this case, we are going to copy them to another model, and I'm going to call that DR bypass. Then select change, and it's copied those strings into another model. Now I'm going to create myself a new view to work on these. I'm going to go to view, but rather than new, we'll show you how to create a view with a name. I'm going down to create plan view. Instead of calling this 6, I'm going to call it bypass. Create. That creates the same type of plan view, only now it has a name. So I'm going to come here now and add on my drainage bypass strings, and you'll see that they now have a direction associated with them. Now most of these are not in the downhill direction, so I'm going to have to do some additional work. I'm going to my strings edit, reverse command. And what I want to do is make sure these are going in the downhill direction. Now I do know the project fairly well. This is where my crest is. So I'm going to highlight that string and reverse it so it goes in the opposite direction. I'm going to have to do the same with this one, so it's coming downhill. The same with this one. The same with this one here, and this one here. Now these are showing in the downhill direction. Now these other ones we can work with later, but just while I'm here I'll change them because I know they are going in the wrong direction as well. For that matter, so is this one. So you'll notice that that's one long string, and what I just did reversed what I did before. So I'm going to have to reverse that again. And if I wanted to accurately depict these two strings for doing this later, I would have to split this at this location. Now the other thing that I was noticing is that if we ever have a join or in our overland flow strings, it has to happen also within 1 meter of our inlets. So keep that in mind as we work on these. Now you'll notice that this string here and this string here, I want them to join together into one string. So I'm going to finish that, and I'm going to up to my strings edit commands, and I'm going to use a join. Now if you're going to join two strings together, you should do it with the directional pick. So I'm doing a mouse down, drag left, and then accepting that, and that defines the end of the string that I want to be connected. So this is the end of the first string. Now I'm going to pick the second string. I'm doing a mouse down, drag left, release. Now that defines this is the beginning of the string and that the end of the string, so that when I accept it, it's joined from the end of this one to the beginning of this one. And you'll see that that is a long overland flow string just like I'm looking for, and the same across here. Now as you remember from our previous example, we moved our inlet just a little bit off the curb return in this location, so we're going to have to fix that now. So let's finish that. Let's go back and add on our drainage12D. And once again, this is the model that gave us the grief. Now, with this overland flow string, because it's the invert of curb, it looks like it is within one diameter of the inlet center, so we're not going to have any problem with that at all. So let's zoom that out a little bit, and let's go use these overland flow strings in our calculations. So once again, we're going to return to our drainage network editor and come across to, first of all, select our network, come across to our globals, down to our utility models, and we're going to select our new overland flow model. So it's going to be drainage, Control D to display, and we're going to go to our drainage bypass. Hit the set pit details on that, and you'll notice now that if we return to our pit tabs and we go pick one of our inverts that we're looking at, one of our inlets, you can see that this one should be bypassing out of the system, so it should be lost. If we went across to pit I05 that we're looking at before, you can see that it is bypassing to I06. Now before we leave this, let's talk about joining these strings together. You'll notice over here that we've got our overland flow strings joining down at this point here. Now this would not work for this model. What we have to do is have the joins happen within 1 manhole diameter of our inlets. So if I was continuing on to the northern part of this job, I would have to remove a couple points off the end of this string. Now to do that, I'd come and use my delete point, come down and pick the end of that string, and there's a couple of vertexes there, so I'm going to get rid of a few at once. And let's go delete the other one at the end, come down to the very end of that string, a couple of vertexes on here. Now depending how many points I found here, I might be interested. You notice when I'm deleting these, they're not disappearing. That's most likely because this network editor is locking that overland flow string. So let's finish that and go back and try deleting those again. Selecting until I get to the end of that string. That's what I want to delete. That's working much better. So the trouble there was that the network editor was locking those overland flow strings. So now it's come back. That overland flow string ends within 1 manhole diameter of that inlet, so it would be recognized for any of the work that we did up above. So those rules again: the overland flow strings must pass within 1 manhole diameter of an inlet center. If there's going to be any joins, they have to be within 1 manhole diameter of the inlet center, and you must draw them in the direction of flow.